Good morning, this is Dr. Turner for Integrated Math 3. Today we're looking at 1.2, which is the rotation of two-dimensional solids. Basically what we're doing in this section is that we're going to take a two-dimensional figure, we're going to rotate it about a certain line. Usually that line is going to be on the shape that we're rotating, and we're going to see what 3D shape is formed. It's kind of a confusing concept, just looking at it abstractly, but once you get the hang of it, it's pretty straightforward. So let's just pull up piece of graph paper here, okay? And so this is how it's going to work. If I give you a shape, and let's say it is a triangle, and so let me draw a triangle here. Change the color here. Triangle going from here to here to here, for instance, okay? And I ask you to rotate it about a certain line, and I would tell you that. Let's say if this is my figure, and I say, I want you to rotate it about the y-axis. If I ask you to rotate it about the y-axis, well then, again, think three-dimensionally, you're rotating it this way. So the easiest way I can kind of describe it is, imagine that you had this shape and you were spinning it. What would it look like if you were continuing to spin it? And so this flat surface ends up becoming round, and this continues out. And so if I am spinning that triangle about that axis, I end up with a cone. Similarly, I could ask you to rotate it about a different line. I could ask you to rotate it, let's say, around the x-axis, in which case you'd be going this way. But if I ask you to do that, similarly, you're going to end up with a curved surface here, and this line would extend out, and so you also end up with a cone. So any triangle that's being rotated about its side like that, you're going to end up with a cone. I could also give you a different shape. Let's say if I gave you a square or a rectangle. Let's do rectangle. Say if I asked you to rotate this rectangle, and I asked you to rotate it about the, to keep it simple, let's say the y-axis. So if I asked you to rotate it this way, well, if you did that, again, it's going to create a spherical surface here and a spherical surface here. And so you'd end up with a cylinder. So any rotation of a rectangle, whether it's parallel or perpendicular to the base, you're going to end up with a cylinder. If you have a sphere, or sorry, if you have a circle, or an ellipse, but we're going to take me for my word, and let's just assume that that's circular for our purposes. If I ask you to rotate this circle about its diameter, then again, you'd be spinning it basically like a coin. And so what you end up with when you are rotating a circle about a line going through it is you end up with a sphere. And this is going around the y-axis, but if I asked you to go around the x-axis, you'd get a similar answer. I asked you to rotate it this way, same thing, go around here, and then you'd again get a sphere. Now the circle is a unique one in that depending on where you are rotating it around, you might get a different shape. So for instance, if I gave you the circle on a graph, and let's say I asked you to rotate it about the line x equals -4. So this line is not on the circle, but I could still rotate it around. And if I did that, what I end up getting, and we'll do this here real quick, what I end up getting is not a sphere like I would usually get, but it's actually, sketch this out here, you actually end up getting a imagine this going around, you actually end up getting a donut. Now the technical term for a donut is what's known as a torus. But again, for our purposes, if you just told me, you're rotating a circle around a line that's not on the circle, you end up with this this donut shape. And again, excuse my crude drawing here. Yeah, so that's what this section is about. So kind of try to use your imagination. If you have a two-dimensional object in front of you, you can kind of try to sit there and spin it and get the concept. But that's what 1.2 is all about. being able to tell me what shape you get that's three-dimensional when you're rotated a two-dimensional shape, either from a line on the shape or a line outside the shape. So hopefully that made sense. If not, email me and have a good day.